Hello and welcome to Okube, an organization building open source solutions for data intelligence. Today we go over Databricks Delta Live Tables DLT, an ETL framework designed to simplify and streamline data pipeline development and management within the Databricks environment. It uses a declarative approach, allowing developers to define their data transformations in SQL or Spark, which helps to focus on business logic rather than on the mechanics of data engineering. DLT features automatic error handling and pipeline recovery, ensuring robustness and reducing downtime in data processing workflows. It also integrates deeply with the Databricks Lakehouse platform, optimizing performance and enabling real-time data analytics capabilities. Additionally, DLT combined with Unity Catalog provides version control and full lineage tracking of data, improving transparency and governance of the data transformation processes. Let's explore how we can create a pipeline to process stock prices data. But before we do, if you want to ramp up your data and AI engineering game, make sure to like and subscribe. For this demo, we will be using the landing volume created in the previous video. If you don't know how to set up Databricks volume, make sure to check out the link in the description below. In the landing volume, we have stock prices stored as JSON files. Each file stores opening and closing prices for a given stock for a given day. Let's see how we can read this data as a data frame using a Python notebook. Here we have a basic Spark command that loads the JSON files from a directory in the volume as a data frame, allowing to explore the data with Spark or SQL commands. One could also use the write command to write the data frame on the disk, or register it as a data table in the catalog. This is great, but building multiple tables in the context of a medallion architecture and managing the dependencies between them can be quite cumbersome. Let's see how Delta Live Tables can help making the process smoother. Here is an example of a pipeline built using DLT. As you can see, multiple bronze tables are joined into silver tables, and aggregations are eventually created at the gold level. Let's head back to our notebook and add a few things to transform our simple reader into declaring a table of a data pipeline. First, we import the DLT module and Spark functions. Next, we use the table decorator to explicitly express that the upcoming functions generates a data frame that represents a table in our data pipeline. The decorator describes the name of the table, some description, the storage location, and other metadata. Immediately under that decorator, we declare our function. The only requirement is that the function outputs a data frame. We will simply wrap our existing code into that get function. If you run the notebook, the output is not a data frame as it used to be, but rather the definition of the table that will be produced when including the notebook in a DLT pipeline. Let's create the pipeline from the Delta Live Tables menu. After providing a name, we select the triggered mode to start the pipeline using manual trigger or schedule. The notebook we just modified needs to be added as one of the source code files for the pipeline. We will be using Unity Catalog for storing our tables. The catalog we select is called Demo and was created in the volumes video. For the schema, we will use default. Because it's a very small dataset, we can reduce the maximum number of workers to 2 to save on costs. All other options will be left as default. Oh, one other option that we need to change is the type of workers we want to use. In this case, we need to modify directly the JSON representation of the pipeline. We are now ready to initiate the first run of the pipeline. For that to happen, simply click the Start button. DLT will go through a few steps, including starting the required clusters, initializing the pipelines, and setting up the tables. Because we are using the development mode, the clusters will be kept alive for a few minutes, so they don't have to be restarted at every run of the pipeline. Once the setup is completed, declared tables will be populated. For small datasets, this should take only a few seconds. The number of rows updated is displayed for each table. You also have access to some metadata, like the notebook used and the target table in the catalog. The schema of the table can also be explored. Each column with its associated data type is listed. Nested structure can also be expanded. Heading over to our catalog, we see the stock prices table in the default schema of the demo catalog. As expected, the data is stored in a nested structure, representative of the raw JSON files used for its creation. The next thing we want to do is to add a silver layer with a strongly typed schema. We head back to our notebook and simply add a new function for the silver table. Notice how instead of reading data from the disk, we use the read function from DLT. This tells DLT that one table is an input to another and will support the detection of the data flow. The function itself is very simple, as it only selects and renames columns from the input bronze table. And that's it. There is nothing else to do, except to run the pipeline again to create the silver table. At this point, the silver table should be available from the catalog and can be explored. The schema is now a lot simpler, with all nested structure removed, and each column having a specific data type. Finally, we head back to the notebook to create another function that will generate the gold table. This gold table aggregates results and compute the mean, minimum, and maximum gains for each stock. Before running the pipeline one last time, we will add a table expectation for the silver table. This DLT feature is very handy to monitor data quality, as it allows to report drop or fail rows not meeting a specific criteria. In our example, we said that any rows for which the price is not a positive value should be dropped. Let's run the pipeline and see the results. The metrics associated with the silver table expectations we defined are available from the Data Quality tab. The number of rows dropped not meeting the criteria will be displayed. The schema of the gold table shows that columns are the minimum and maximum gains for each stock. Refreshing the catalog reveals the newly created gold table. An interesting feature is the availability of the data lineage. This is automatically generated when tables are part of a Unity catalog. All table interdependencies are tracked and presented graphically. A demo of DLT would not be complete without exploring how we can read data as a stream. Using Spark and DLT read stream functions, we can ensure to treat data as a stream and only process incremental data at each run. In this case, because we changed the nature of the tables, we need to run a full refresh, meaning that all tables will be recomputed entirely. Notice that the bronze and silver tables are now streaming tables. In the first run after the full refresh, all 52 rows have been processed. But if we run the pipeline again, we see that the 4 lines of the gold table have been updated, but no new lines have been created for the bronze and silver tables. This is because no new data is available and only increments are processed. This concludes our demo on Databricks Delta Live Tables. Today we have learned how to build a pipeline by creating 3 simple functions in a notebook. The DLT framework is very powerful and simplify a great deal the creation of data pipelines by automatically identifying the data flow, managing the schema changes, and allowing to reprocess all historical data. It saves a great deal of headache to a data engineer. We hope it was helpful. Are you already using DLT, or are you planning on using it soon? Let us know in the comments below, and see you next time.